Thank you. Okay, just to let you know, I record each lecture, and so what I'm going to do is wear this microphone. It's blinking, which can be a little bit of a distraction. It's not like my heart rate monitor. This isn't, what do they call that when you pacemaker? I'm not Iron Man. This is just a microphone, and so this records the audio. It's also capturing the screen. I'm loading it onto YouTube, and what my methodology will be is that after each lecture, it takes a while to process the video file, but then I'll post the link on MU Online. I won't email it to you or anything like that, but if you need to review a section of the lecture because you couldn't understand something, want to go through it again, or if it's a spreadsheet demo and you need to take a look at the formulas that I used a second time, the recordings can be useful for that. I'll have 1 or 2 instances during the semester where I'm away at a conference or at a meeting, and then I'll just post the recorded lecture online. Or maybe you'll be sick, and so this is a way for you to access the lecture where you maybe wouldn't otherwise have the opportunity to go through it again. On the other hand, if you are like, don't want to be on mic, then whisper your question, and I'll try and hear it, but the microphone won't. You know, like if you're really paranoid that if your microphone gets recorded, it'll take your voice away, that sort of stuff. Thank you. Let's go through a couple of announcements. We'll look at the syllabus and we'll just dig right into the material today. The first item I wanted to remind you of is that you should either buy or rent the textbook as quickly as possible. Did everybody get the email I sent out at the beginning of maybe last week to let you know the great bargain that's available on Amazon to rent your book? I think, what is the book to rent, 38 bucks? Or was it even less? Yeah?
I have it already.
Yeah? You mean the ebook?
Yeah.
Sure. iPad, iPhone, I don't know anymore. Yeah. You can use it in whatever format you'd like. Yep. That's just fine, as long as it's the same edition. There are, 9 other editions out there, previous editions, where they've changed the homework around, and that wouldn't be good to buy the 9th edition, although the text is mostly the same. Get it as quickly as possible because here's your first homework assignment, homework number 2A. Does everybody have a copy of these notes? You can write in the margins off to the side. You've actually got your first 2 assignments. I'm going to give you this introductory assignment right now. Since it's been a while since I taught most of you, and some of you I've never taught before at all, I want an opportunity to get to know you a little bit better. And so I'm going to encourage you to stop by my office during my office hours with this introductory assignment. You don't get points for completing the assignment unless you come during my office hours. So that's part of the thing, is to let you know when my office hours are. Break the ice, because sometimes it seems like students are a little bit shy and nervous about coming to the professor when they've got questions or when they're confused about something, and I don't want you to feel shy and then have it hurt your grade. It's always a pity when, you were willing to do the work but fell behind and then ultimately didn't learn the material. So introductory assignment is due Friday before noon. And the reason why it's before noon is that that's the end of my office hours for the week. As you can see from the syllabus that I handed out earlier, my office hours are Tuesday from 12:30 to 2, Thursday from 12:30 to 3:30, and Friday from 10:30 till noon. So this introductory assignment's pretty easy. It's the easiest points of the semester, stopping by and shooting the breeze with me. And I think there's one technical thing I ask you to find out is, what is it, the pressure? What's the pressure at the deepest part of the Pacific Ocean? So you're going to actually have to Google that or something to find that, right? So, all right. That's homework 1. It's due on Friday. And then homework 2A is due the following Tuesday, September 2nd. Now, of course, we don't have classes on Monday because it's Labor Day, but we'll just have our normal schedule here on Tuesday, and homework 2A will be due that day. So those are the announcements. So let's just jump into this syllabus a little bit more. And the syllabus mentions that my office is just down the hall at EL 113. It's the first office on the right as you come in the building from those far doors. I've got my office phone and email address listed here, and there's a reference to all of the university policies that govern academic behavior, like the excused absence policy, computer services, inclement weather, and so on. Feel free to read through those university policies at your leisure. The purpose of this course, though, is the principles of hydrostatics and hydrodynamics with computer applications. This course includes a lab, and we have lab today, as a matter of fact. We'll all be meeting. Our lab is scheduled from 2 until 5 o'clock today. We'll meet back in the lab. There's some desks there. We're going to have both an introduction to safety as it pertains to the equipment we'll be using this semester, and also I'm going to talk to you about the required lab format. So we have 3 hours set aside each week for lab, and we rarely will use the full 3 hours. So today, we'll probably finish early today, you know, like maybe at 4:57 or 4:58 at the latest. All right? I guarantee that we'll finish at least 2 minutes early today. That's my humble promise to you. The course objectives is to continue your education in the science of mechanics, introduce fluid properties. We did that today, some fluid properties. Start talking about fluid statics and closed conduit flow. Next semester, the continuation of this course is a hydraulic engineering. That's CE 331. And it's important that classes be taken in a 1-2 sequence because they're so closely interrelated. Next semester in hydraulic engineering, we'll start talking about open channel flow a little bit more than we'll be able to touch on it this semester. You can see a list of course outcomes here, and I won't read through that entire list. You're welcome to read through the list of 10 course outcomes, but often you'll want to jump right into the grading scheme here and see that we have 2 midterm exams. Each one of them is worth 19%, so together they account for 38% of the course grade. Your homework assignments are 17% of the course grade. Quizzes are 10%, and we'll have quizzes on average a little less than once a week. You'll sort of feel it when there's a quiz in the air, like there's a quiz brewing, you know. It's sort of like a storm. You can sense it. Oftentimes it'll be after you submitted a homework assignment, or you'll just start to know. Final exam is 20%, and then the lab assignments, whether it's a report or some other activity that's assigned with the lab, together accounts for 15% of the course grade. Any questions about the grading basis? Okay, I've got a schedule of topics, and that's in the syllabus, but as far as the schedule goes, what I think is more useful and important is this gray shaded spreadsheet table that I've given you. Does everybody have a copy of the course schedule document? What it shows is every class for the semester, lectures 1 through 28, the subject for each of those lectures, what book chapter corresponds to it, and I really encourage you to use the book not only just to find the homework problems, but this textbook can explain things in a different way than I'm going to be able to explain it. And so it's an alternate point of view to reinforce the material you're supposed to learn, and it's important for you to read the textbook. Whether you do it or not, it's still important for you to do it. So, you know, the A and B level students will be the ones who take the time to read the explanations in the textbook. This table also lists the homework assignments for the semester, when they're due, and then the labs that we're going to have each week. And so the labs will be every Tuesday, and the lab that we're doing today, for example, the homework assignment that goes along with that will be due a week later. So it'll be due during lab next Tuesday. So this one page here, the course schedule, gives you a glance of when the exams are. We'll do the exams, as you can see, during our lab time, just so that gives you a little bit more time to solve the exams. So our first exam will be on the 30th of September. Our second exam is on November 18th. And then the final exam is comprehensive, but it'll have added emphasis on the material that isn't included in the first 2 exams. You can see that we even have the final scheduled for the Thursday, the 11th of December. So there's no mystery about the course. It's all there before you. Any questions about this course schedule? The meaning of anything that's on here? The homework assignments are labeled to correspond with the book chapter. So the reason why there's a homework 2A and 2B is because both of those assignments correspond to chapter 2. I don't know why I do it like that, but I do. I think I've been using this textbook for a long time. I think it's excellent, and so I pretty closely follow the way the material is presented in the text, and that's why the homework assignments are labeled, I guess, that way. So let's jump back to the syllabus here and take a quick look at the homework and academic dishonesty policy. The schedule of labs and the schedule of topics is in that standalone schedule that I've just given you. My homework and academic dishonesty policy is that as far as homework goes, I don't accept late work. You do the assignment on time, and it should be here on the table before class starts, already stapled together, not folded though. Some of the other professors ask you to fold the work together. I don't want it folded. It doesn't matter, personal preference, but it should be stapled on engineering paper and at the front of the table here before class starts. And I don't accept late work unless it's an official university excused absence. And the way that you get that is outlined in the course policies that I link to. There is a form that Student Affairs wants you to fill out, and then the Dean of Students will make the determination of whether your excuse is going to be university excused or not. And so as far as honesty goes, one important thing that I'll mention to you is that copying homework assignments is not allowed, and that means you shouldn't copy another student's homework assignment, and you shouldn't copy information out of the solution manual. The homework problems to this, the solution manual is out there on the internet, and I'm sure you can track it down if you want to, but I'll really encourage you not to do that. Number one, because it's just going to hurt your education. If you short-circuit the growth process that's required to get stronger, then you're not going to know the material for the quiz, you're not going to know the material for the exam, and most importantly, you're not going to know the material when you go out into professional practice if you copy the homework problems out of the solution manual. But another reason to not do that is that once in a while in that solution manual, there's errors, and I know what those errors are, but you may not know what those errors are. And so when I'm grading the homework, it's really easy to tell who's copied the solution manual because you'll use the mistake that the author has in the author's solution manual. And you'd think after 10 editions, he'd give me a solution manual that's right, but no, it's chock full of errors, and I found them. So twofold reason not to copy the homework is because it's wrong and it hurts your learning, and also it's easy for me to catch you, and I'll give you an F in the class if you do it. So the smiley faces and the frowny faces helps to distinguish between what I consider acceptable behavior and what's inappropriate collaboration. So it's okay to talk about the homework with other students, and it's okay to check your answers with another student, and even to help another student find mistakes in their solution. But what's not okay is to sit at a table with a student and both of you at the same time are working the same problem at the same pace. And what's wrong with that is that inevitably when you have two people sitting together, one of them works more quickly than the other one. It's not that one's smarter and one's dumber. It's just that they work at different speeds naturally. And so the one who naturally would work a little bit more slowly will just sort of copy what the fast one is doing to keep up, and it won't sink in the same way as if they'd done it themselves. So don't sit at a table and work every step of a problem with somebody together, because group working problems simultaneously just means that you're going to be underprepared when it really counts. Another thing you shouldn't do is give your completed homework assignment to another person, because you don't know what they're going to do. If they copy it, then the grader is going to say, these two assignments look identical, and both of you are going to be in a little bit of hot water for inappropriate collaboration. So when you finished with your homework assignment, hang on to it until you turn it in. Now, it's okay to collaborate, but just not to collaborate inappropriately. Any questions about that? All right. Hopefully it won't come up again. The next 2 pages are tables of course outcomes, implementation method, evaluation method, and how that ties into both the degree profile and our program outcomes. I don't know if any of you will be really interested in that, these 2 pages, but it relates to like your whole education, what are the main goals that we have for our BSE degree? And so this is just showing how this course achieves some of the program goals that we have for your BSE degree. Any questions about the syllabus? All right. So you've got the schedule, you've got the syllabus, you've got the introductory assignment, and today in lab I've got some handouts for you. I won't give you that now. And you've got the class notes for today, right? So much paperwork. It would be useful if you have a 3-ring binder that you hang on to for all of the handouts I'm going to give you through the semester. I'm going to give you notes each class period with some space in the margin for you to write down your work. So I'd encourage you to have a binder to keep it all together. Okay. Well, let's get into the material unless there's any questions before we move forward. We'll start by talking about the difference between pounds mass and pounds force. And this is confusing. And the traditional unit system, also sometimes called British Gravitational Units, BG, is what we use when we're talking in terms of inches and feet and pounds and ounces. I used to teach overseas, actually. I used to teach in the United Arab Emirates, and I'd occasionally throw problems in the traditional units for students over there just to see what it's like, and they were absolutely bewildered by the British gravitational system. They were thinking, why are there 12 inches in a foot? Why not 10 inches in a foot? Wouldn't that make more sense? And I had to say, yeah, of course that would make more sense. But that's the SI system. In terms of force, we have a Newton, and a lot of this will be a review for you. A Newton is a kilogram subjected to an acceleration of 1 meter per second squared. In traditional units, we have what's called a pound of force. And a pound of force is analogous to a Newton in that they both have units of mass. The unit of mass in SI units is a kilogram. The unit of mass in BG, British Gravitational or traditional units, is a slug. Instead of accelerating it at 1 meter per second squared, if you accelerate a slug at 1 foot per second squared, it's going to require 1 pound of force in order to achieve that level of acceleration. So that is a slug can be subdivided into 32.2 pounds of mass. Remember, a slug is a measure of mass, but the confusing thing is that there is both pounds of force and pounds of mass. And so you may be wondering, how do they fit together? How do you keep straight pounds force and pounds mass? Here's how I think about it. That you can have a pound of force by taking a slug and accelerating it by 1 foot per second squared. Because remember, up here earlier I said a slug accelerated at 1 foot per second squared is a pound of force. So that's one way to think of a pound of force. Another is this way, and it's maybe the more meaningful way. A pound of force is what you get when you have a pound of mass accelerated at 32.2 foot per second squared. And what's significant about 32.2? What is that? That's G, right, acceleration of Earth's gravitational field. So if I have a pound of mass on Earth, it's going to exert a force of a pound force. If I accelerate it at any other gravitational constant than 32.2, then pound force and pound mass aren't going to be the same. But when they're static, the two are equal. All right? Put a big star next to this slide because you'll be coming back to it in Chapter 4. You'll be scratching your head and be thinking, I remember we talked about pounds force and pounds mass, and you'll be able to find this slide again. Okay, so if we just talk a little bit more about basic units. By the way, when do we finish? It's at 12:15, right? These classes on Tuesday and Thursday always throw me for a loop. So if I start talking too long, do the thing with your backpacks, the zippers. That'll let me know. When I start hearing zippers, I'm like, oh, I'm running out of time. All right? And if I ignore your zippers, just start standing up, well, it's been great, you know, and just make your way towards the exit. All right? You don't ever have to stay late for me. Weight is the effect of acceleration on mass. You'll notice that in the handout I gave you today, it's just natural for I wanted to say, how much will the cup weigh? We are accustomed to talking in that manner when we're thinking about measuring something, but really I had to force myself, oh, it's not how much does it weigh, it's what is its mass, because I was going to be measuring it in grams, not in newtons. Weight is a measure of force. And so 1 kilogram of mass on Earth has a force of 9.81 newtons because in SI units, acceleration is 9.81 meters per second squared. Our basic units of temperature, absolute terms, is Kelvin. And remember, probably back to chemistry, you converted between Kelvin and Celsius with the conversion factor of 273.16 is how you can convert between the two. The freezing point of water is 273.16 Kelvin, 0 Celsius. Work or energy is measured in joules, and a joule is a newton multiplied by a meter. So it's the amount of energy required to cause a newton of force over a meter of length. And so if I was going to lift something, if I had something that weighed 1 newton, if it was exerting 1 newton of force, and I pushed it through 1 meter, then it would have taken me 1 joule in order to accomplish that. And then power is where time comes into it. It's the exertion of a certain amount of energy per time. And so a watt is when you're exerting 1 joule per second. It's a rate. All right. If we want to convert between SI and traditional units, the textbook gives us a handy reference in the front of the book. It's got all the information that you'd want to do to convert between SI and traditional units. So it's got length, speed, mass, density, all of it. So I'm saying here that a foot is 30.48 centimeters. You can find that same information here on the table F1 in your front cover. It also has some commonly used equations, and that's nice. They've just started adding these equations in the 10th edition that we're in now. Previous versions of the book didn't have that. Conversion between slugs and kilograms, pounds force and newton meter. Power is measured in terms of foot-pounds per second, sometimes also called horsepower when we've got 550 of them. Here's a tricky one, is the conversion between Fahrenheit, which is, I'll always think in Fahrenheit. I mean, I can maybe do meters and kilometers, but Celsius is just absolutely meaningless to me. Even when I lived in a foreign country for 4 years, still Celsius never made any sense to me. But the way that you can think about a Fahrenheit is that the degrees themselves are smaller. So a Fahrenheit degree is only 5/9 the size of a Celsius degree. And then there's also the difference of their freezing point. In Fahrenheit, it's 32 degrees for the freezing point of water, and it's 0 for Celsius. Absolute temperature in traditional units is measured in Rankine. And so degrees Rankine is 460 plus whatever the temperature is in Fahrenheit. So let's just work an example here today. I'd like you to give this a try. If it was 43 degrees Celsius in Dubai yesterday, what is that in Rankine? So you'll need to convert between Celsius and Fahrenheit, and then Fahrenheit to Rankine.